Okay, for this next part, we are going to learn how to solve using a method called elimination. But first of all, we're going to start by solving this system here by substitution. So I'm going to give you a moment or two to do that. Just put me on pause, try it out, see what you can do, and then go from there. Okay, as you can see, this one is a little bit more difficult than the ones we have been doing prior to this by substitution. None of the coefficients in either of the two equations have a 1 in front of them. So this makes it a little bit trickier because we ended up solving and we had fractions in our answer. I took this second equation and solved it for the x because it was the smallest coefficient, and when I divide by 2 it does work out to be a nice decimal number. I either go into full whole numbers or integer numbers, or otherwise I end up with 0.5s to work with if I need to take it to decimals. Now I left it in fraction form. I expanded it, simplified it. I ended up with my solution being 20, -6, but it was quite intense. So I'm going to show you another way. This method of elimination is actually quite slick with some of these equations that don't work as well with substitution. So what we're going to do here is practice some columnar adding and subtracting. Well, adding first, and then we'll get into subtracting in a minute here. So when I'm doing this column adding, I'm going to take my x's and add those together. So 3x's plus 2x's is 5x's. And then I have plus 1y, but then I take 1y away, and I get 0y's. Okay, so we don't normally write 0y in. I could plus 0y, but normally we would just leave that as a plain old 5x. In part B, if I add these columns together, 4x's plus 7x's will be 11x's. And then a minus 3y plus 3y, again, is 0y plus 0y, which really is just 11x, and the y disappears. Part C, I have 9y over the 2x. I can't put those together because they're not like terms. Similarly over here, I can't add these together, the 2x and the minus y, because they're not like terms. So what I'm going to do is rewrite that top one. I'm going to move that minus 2x to be first, and then I have a positive 9y, so I'm going to put plus 9y. And then I'm going to recopy the second one, and now I've got the x's lining up and I've got my y's lining up. So if I have negative 2x's and I add 2x's, because this really is positive 2x, my x's now disappear. I get 0 x's out of that. A plus 9y minus 1y would be plus 8y. And if I have 0 x's, add 8y, that just results in 8y, a positive 8y. So this time I've eliminated my x's. So here's the word elimination, and notice we eliminated y, and in the last one we eliminated the x. So what do you notice about the answers? Why did this happen? I noticed that one of the variables were eliminated. And why this happened, let's look at our examples here. I had a positive 1y and a negative 1y. I had a negative 3y and a plus 3y. Here I have a minus 2x and a plus 2x. This happens because my coefficients of one of the variables are opposites to each other. One's a plus 3, one's a minus 3, one's a plus 1, one's a minus 1, one's a minus 2, one's a plus 2. So that's what you want to answer in this section here. Okay, so I wrote in one of the variables was eliminated, and this happens because the coefficients of one of the variables are opposites of each other, like a minus 3x and a positive 3x. So I'll put that in here, minus 3x, and then we had positive 3x. Or we had a positive 1x, y, I think it was y, not x, and a minus 1y. Okay, now here we're going to subtract. So last time we were adding the columns together. This time we're going to subtract our columns. So if I have 4 x's and I want to subtract all of this, so I have 4 x's and I'm going to take away 2 x's. 4 x's take away 2 x's is 2 x's. And then I have positive 3y, and I'm going to take away a 3y. Positive 3y, take away 3y, I get 0y, and that eliminates the y's, and I get 2x as an answer for that one. Column subtraction here, I want to take away all of this second one. So I have 7 x's, I'm taking 3 x's away, I still have 4 x's. I have a negative 4y, and I'm going to take away a negative 4y. Taking away a negative makes it adding. So negative 4y plus 4y is 0 y's, which leaves me with just 4x here. In the last one, we have 2 x's, and we're going to take away 2 x's. I get 0 x's, and then minus 5y. Take away a negative will be plus. 5y plus 6y is plus 1y, or just plus y. So 0x's plus y is just y. What did I notice about the answers? I am left with just one term in each one. I don't have either the y's or the x's in each one. And why did this happen this time? I notice that I have a plus 3y and a plus 3y here. I have a minus 4y and a minus 4y. And I have a plus 2x and a plus 2x. If my coefficients are identical for a variable, if I subtract, I'm going to eliminate that variable. So I'm going to write that in here. Okay, so one of the variables was eliminated each time, and this happened because when the coefficients of a variable are the same, like a positive 3y and a positive 3y, or a minus 4y and a minus 4y, or positive 2x and a positive 2x, subtracting will eliminate that term. So that's the whole premise behind this elimination. To solve by elimination, the coefficients of one of the variables must be the same or opposites. Try that again. Okay, must be the same or opposite in the two equations. If they aren't, what we're going to end up doing is we're going to multiply, just like we did with the fraction questions on the previous lesson. We're going to multiply every term in the equation or equations by a constant to make one of the coefficients of one of the variables be identical or opposites. Whoops, I'm not sure what. When the coefficients are exactly the same, they have the same sign, we're going to subtract the equations. Subtract. Let's try that again. Subtract the equations to eliminate the variables. And when the coefficients are opposites, we're going to add, because adding will eliminate the variable. Okay, so this first example here is the example we did for warm-up using substitution. Now, if you look at this, do you notice that our y's, one is a minus 3y and one is a plus 3y? We have the case where we have opposites. So what I'm going to do is I'm going to take these two equations, equation 1 and equation 2, and I'm going to add. We're going to add. Okay, so we're going to add these together in columns, and by doing so, we're going to eliminate that y coefficient. So if I have 4 x's and I add 2 x's, I get 6 x's. A minus 3y plus 3y, they go away, so I don't have to write that in. A negative 10 add 22 will equal 12. So now I've got a really little equation that I can easily solve. I've got 6 times x equals 12. Using our solving equations or inspection, we're going to end up with x being equal to 2. I already have my x solution here. All I need to do now is get the y, and to do so, we go back to what we know about substitution. We're going to sub x equals 2 into, and then we're going to pick one of the two equations, and it doesn't matter which one. I'm going to pick the second one only because I see lots of positives there, and I don't have to worry about negatives as much, but it really doesn't matter which of the two you sub it into. All right, so I have 2 times the x, which is 2. 2 times 2 plus 3 times y is equal to 22. 2 times 2 is 4, plus 3y is equal to 22. And now I'm going to solve that for y. Subtract 4 from both sides. And I get 3y equals, 22 take away 4 is 18. Divide both sides by 3. I'm going to get y equals 6. So my solution is 2, 6. Okay, so what I'm going to do over on the side here is I'm going to summarize our steps. First step today, tomorrow's lesson, we're going to add the step where we have to force the coefficients to be the same. But for today, the first step is going to be to look for coefficients that are either the same or opposite. And if they're the same, we subtract to eliminate the variable. If they're opposites, we add to eliminate that variable. Then we can easily solve like we did right here. Yeah, undo that and do this in a different color. Then we're going to, whoops, dang it, I'm doing the wrong thing here. There we go. And then what we're going to do is there we go. We're going to solve that little equation we have once we've eliminated the one variable, and then we follow our substitution to get our next step. So I'll type those in here. You can put me on pause. Okay, try the remaining examples, see what you can come up with, and I'll post solutions on the next video.